So hello everybody, my name is James Thomas and I'm a developer advocate working for IBM and our cloud division. And the title of my talk today is Taming Dragons, and hopefully in a couple of slides time it will become apparent why I've used that metaphor. But what my talk is really about is it's about how as developers building service apps can maybe try out some of these different service providers without having to know the intricacies of how every provider works and how you configure an API gateway and every different single service provider. And also maybe if you want to move service apps between different providers or run them in multiple providers simultaneously, how you can do that and make that a little bit easier without having to re-architect your entire application. And to do this, I'm going to be showing you how to use a really popular open source framework that recently has announced support to make this easier to do. And that framework is called the Serverless Framework. And as of the start of this year, they announced what they called multi-provider support, which provides you with a nice kind of abstraction layer, which makes kind of getting started and using some of these providers a lot easier to do. We'll kind of have a look at how you might do that and some of the challenges involved in kind of using multiple service providers. Now, I think 2016 was actually a really big year for serverless. I think it's kind of the year that serverless took off. And the reason I think that happened is that all of the other providers launched competing kind of serverless offerings, right? So in around January 2016, IBM came out with one called OpenWhisk, which we'll be looking at a little bit today, which is open source and now been donated to Apache. You have Azure Functions has come out recently. You also have Google Cloud Functions. There's some smaller providers like WebTask and IronIO, and there's a couple of providers which build on top of Kubernetes, if that's what we're using. Things like Efficient is a popular solution. And it means that serverless is not just an AWS thing anymore, right? Serverless began on Amazon's cloud back at the end of 2014 when they launched Lambda at their conference about 2.5 years ago now. But that obviously became a really popular service as developers, and all the other cloud providers decided to kind of get on board. So now, whoever your cloud provider is, I can kind of guarantee you that they have a service platform for you to be able to play with. You know, you can't really go a day on Hacker News without seeing someone talking about a kind of new service provider. And as developers, as you're using service and building service apps, this is kind of what you want, right? You want competition between the different vendors because that drives evolution, that drives new features. And we get to kind of play with all the new technology they come out with. So I think this is a really good time to be involved in serverless because you can have lots of different providers to be able to play with. But if you've been using serverless for a while, right, maybe you're an early adopter of something like AWS Lambda, you might think, well, hold on, right, it's all just serverless, it's all just kind of functions on demand, right? Why would I, switch providers or think about using different providers for different applications? Is there any real difference? Don't they all do the same kind of thing? And actually, when you look at it now, there are some key differences between the providers, which mean that you might choose to think about which provider is most appropriate for the serverless application that you want to build. And I think there's a couple of key reasons why people are thinking about using different providers or switching providers for different serverless apps. And the first of those might be something like performance. So again, maybe you're a super early adopter of serverless, you saw why it was so brilliant back in 2015, something like that, before really you had any choice around who your vendor is. So maybe you're using obviously AWS Lambda, but it just so happens that your company, all their resources and the rest of their cloud infrastructure is all on something like SoftLayer or Microsoft Azure. And actually, you think now, because you can run your service app in the same provider, you can actually get much better performance, right? Not doing all those API calls across different cloud providers. It also might be performance in terms of geographic performance, right? Maybe you want to expand into something like a new region, and your particular service provider doesn't support that region at the moment, right? Maybe you want to go into something like China. And it means that actually you can just pick another service provider and decide to use that to be able to expand your geographic reach. So performance is one issue, I think, especially with people who adopted service technology early before maybe the rest of their cloud providers had, that they kind of mainly use adopted serverless. Runtime support is another kind of interesting thing people are looking at. I think if you look across a lot of the serverless providers, there's a couple of core runtimes that they all support, right? So Node is like the first-class serverless language. You can use Node on pretty much any serverless platform. But also, it's one of the ways they're trying to differentiate themselves is by adding kind of new and slightly more interesting runtimes. So, for example, in OpenWhisk, you can build Swift functions out of the box. If you're big into .NET and that whole stack, Azure Functions has really, really good support. So again, one of the ways that the vendors are trying to differentiate themselves is by adding different and more interesting runtimes, maybe a newer version of Node than you can get on something like Lambda. And so you might decide to try a different service runtime to get a particular kind of environment. And it's also about extending your environment. So with OpenWhisk, for example, you can actually extend your service environment yourself. You can run pretty much anything you can wrap inside a Docker container by pushing that image into the platform. So if you want to take advantage of that, maybe that's something you look at. Another kind of aspect that people are thinking about when they're thinking about providers and which one to use is around the use of open source and open source platforms. I think everyone who uses the cloud has this kind of nagging worry that they're signing up to a load of APIs and services which are proprietary and that they'll never be able to get away from if the pricing changes or they turn the service off. Think about pass.com. And what happened there. And so lots of people actually like to use cloud services which were built on kind of open source components. And now actually some of the open source or some of the service providers, their platforms are open source. So OpenWhisk, which has been donated to Apache, is Fission and things like that. They're built on top of Kubernetes, Iron Functions as well. So actually now maybe you decide that you prefer to build serverless apps on a platform that is under the covers actually open source, to kind of negate some of that worry about kind of vendor lock-in. And then the final reason that I hear people talk about is around, in some cases, thinking of going multi-cloud, right? Maybe you think the way to build resiliency in your application is to go multi-cloud, right? Maybe have a backup running in a completely different kind of cloud provider, or maybe run different bits of the app in different cloud providers for various reasons. And obviously now you can kind of do that, right? Because now you have a lot of vendors to be able to play with. So there's actually, I think, a number of different reasons, from performance to runtimes of open source and multi-cloud. Well, people are now considering, right, when they're building service apps, which provider is best for my particular applications. And you might, as a service developer, be really excited about this, think, oh, this is great, right? I've got all these providers and they've got all these different capabilities, and I can just pick one and I can use it. And it's all just serverless, right? It's all functions as a service. It's all the same kind of concept. So I can just, get my account and start to use it, and I'm not going to have any problems. Well, unfortunately, that is where the title of my talk comes from, because if you are used to one particular service provider and you go to use another and expect it all to work, this is where the dragons will come out and they will chase you into a pit and they will set fire to you, and you'll be turned into a kebab by Drogon here, because serverless is still a very emerging space, right? It's still very new. It's only existed as a concept for about 2 years, and it means that there is no standardization between the different serverless providers, right? All their APIs are completely different, and the way that you deploy applications and the way you package them and you connect to event services. And so it means that your knowledge of using one serverless provider doesn't necessarily translate to another. And this, I think, for many people has been a bit of a barrier to adoption, right? If you're very comfortable with Lambda, maybe you'd like to use a new runtime on, Node 8 on something like OpenWhisk or Azure Functions, but you think, well, is it worth learning all the intricacies of that cloud platform just to be able to use a newer version of Node? Maybe I'll just stick with that. And I think, it's been a bit of a barrier to adoption of people trying out the different providers, which is why I was kind of really excited to see one of the big open source frameworks involved in service development kind of step up and start to get involved in helping to reduce the level of knowledge you need for trying out some of these different providers. And that framework was called the Serverless Framework. There's a number of different frameworks for doing serverless kind of development. There's things like Apex and Zapper and Chalice as well. I think it's fair to say that the Serverless Framework is the most popular framework out there. It's got, if you look on GitHub, it's got like 14 bazillion stars that you can kind of play around with and start to use. And it's been around for about 2 years, so it's quite mature as well. And actually, the Serverless Framework grew up in a time where serverless was only available on AWS Lambda. But last summer, I was kind of digging around in the source code to understand how it works, because I've been kind of trying it out. And I was really interested to see that they'd started to make some changes to the framework to actually support different providers. You could actually support different providers and do some kind of architectural changes in that at the same time. And I work at IBM and have been heavily involved in kind of doing OpenWhisk. So I was like, well, maybe I could start to add in OpenWhisk support. And I'm kind of proud to say I kind of took on this and worked on it for a couple of months. And as of Serverless Framework 1.6, which announced in January, actually multi-provider support was kind of released to the world, and OpenWhisk was the first provider which provided implementation. So the wonderful service framework, which gives you this whole kind of CLI and workflow for building serverless apps, and gives you a nice abstraction layer from the provider, you can now use those same tools with any of these different providers. And OpenWhisk was the first one to kind of come out with support. And I'm happy to say that the other providers have kind of come on board as well. So about a month later, in I think the 1.7 release, Azure Functions released their plugin for the particular toolkit. And now we have Google Cloud Functions is in there as well. So it means that you can use the same command line interface, the same configuration for your application, the same kind of workflow of development and pushing to production and monitoring, all the same commands work across any of these four providers, right? So it makes it much easier to be able to try them out. You can get the same kind of development environment. So if you're not familiar with the serverless framework, what it gives you is it's an npm global command install with npm install -g, and it gives you the CLI tool called Serverless, which you use to do the whole kind of scaffolding and deployment of your application. It allows you to, using Serverless Create, it allows you to create boilerplate apps. So it's kind of, you choose a template for your provider and the runtime, and it will scaffold you a new application with all the YAML file and the JavaScript files and things like that all set up, ready to deploy. You can go in and start to play with blanks. And then when you finish doing your code, you type serverless deploy, and it will bundle up all your application dependencies, and it will work out which your provider you're using. And then it will go and it will deploy your functions to that cloud provider. It will set up all your events that you want to connect to, your object store, your API gateway, and then it will wire functions to those particular events. And it means that you as a developer don't really have to know under the covers that it uses CloudFormation on Amazon or resource templates on Azure or things like that. It provides you with a really nice kind of getting started experience, which actually makes it much, much easier, I think, to get started with serverless development. And it's the community, actually the open source tool is very, very popular. It has a huge community of users. The people behind it are really, really cool. And there's lots of third-party plugins that the community has developed to make doing serverless development really, really awesome. So it's just a really great framework, and it's not surprising that it's super popular. Now, at the heart of any serverless framework application is this YAML file. So this is a YAML file that you have in your app, which kind of describes your application kind of configuration. This is what the tool uses to go and then deploy that to the cloud. So this is a real live YAML file that you could deploy. It's got a little service on called, you kind of give it a service name for your microservice. It has a provider name and flag that we'll kind of look at in a minute. And this is how you configure a serverless app using the framework to deploy a kind of new application to your provider. So you can say, I want to deploy a function. It has this handler file, which is a local JavaScript file that you're going to deploy. I want you to call the hello function whenever my serverless function is invoked. You can set all of the runtime parameters for, like, what runtime you want to use, how much memory, how much timeout in the YAML file. And then you can also define your event sources, so you can connect it to things like API gateways, to object stores, to message queues, directly through the YAML using really, really kind of easy to do configuration. And then when you type service deploy, it's going to take that, it's going to understand what's in there, it's going to go and configure your cloud resources for you. And it just makes it really, really easy to get started. So at a high level, right, the multi-provider support that they included meant that you could actually change that provider name to different providers to target different service platforms. So at a high level, and we'll get into the details of how this actually works in a minute, if I wanted to deploy this application to something like OpenWhisk or instead, or Azure Functions or Google Cloud Functions, all you have to do is change the provider name, and then when you type service deploy, now it's going to go and target that different provider. Now, obviously, you have to have obviously signed up for an account with that provider. You have to have got your credentials, and you have them in your environment as kind of environment variables or config file or something like that. But actually, that's all you really have to do from a configuration standpoint to deploy your app to a slightly different provider. And this is hopefully why a really, really awesome feature, right? It means that the barrier to getting started with a different provider is much, much lower, right? I don't need to go and read all the details or exactly how you package and deploy application. The framework does that, or how you configure an API gateway, and it kind of gets much easier to get started. So let me show you how at a kind of technical level you would actually go starting with one of these new providers, and hopefully kind of, as I said, release the dragons or release the platforms, give you the confidence to go and try some of these out. So let me hide my slides now and show you my terminal. So I obviously, as a key user of serverless, I've already got it installed and I've got all my configuration set up and that kind of stuff. So you can see I have this command service that you run, which gives you all the CLI commands to do a full life cycle of building and deploying serverless apps. And what most people do to get started is they type service create. And what service create allows you to do is it allows you to give it a template for a particular provider and a runtime, and it will build you a scaffold application which you can then go in and deploy and start to kind of fill in your own code. So you can see obviously there's lots of templates for AWS because it's been around for quite a long time. But you also notice now we have templates for the different providers. There's one for Azure, there's one for OpenWhisk, there's 3 for OpenWhisk actually, there's one for Google as well. So if I wanted to get started with another provider, right, I could start with one of these scaffolds and deploy it without really having to know too much about that particular provider. So let's do this now for OpenWhisk. I'm going to say template OpenWhisk Node.js, pick it up path, hello world, and that's going to scaffold me a kind of hello world serverless app under the hello world path. So you can see here's the scaffold, and again the structure and the configuration files are exactly the same for any different provider. It's not provider kind of specific. So you can see that you have obviously a handler file, which is your JavaScript file it's going to run, and in this instance it's just kind of hello world service, right? It's going to return you a kind of greeting on demand. There's a package.json where you obviously can put all of your module dependencies if you want to use that kind of stuff. There's a README, obviously with kind of instructions about how to set up that particular provider and how to get your credentials into it. And then again, as I said, at the heart of every serverless application is the YAML file where you define the configuration, right? So it's got a service called hello world. We have the provider name filled out for you, and then if I skip past all the comments, you can see this is just a really simple basic hello world config of creating one function called hello, which has that particular handler. And again, it shows you how to set up the events and sequences for your runtime and things like that. So again, without really knowing too much more about this particular provider, right, all I have to do is install the provider configuration or the provider plugin from NPM, and then I can type serverless deploy, and hopefully this will work. And what it's going to go and do is it's going to package up my service, going to go and create my cloud resources, deploy to this endpoint. Obviously, I already have an account and I have some environment variables set with my credentials. You have to watch me doing that. But it says I now have an action. In OpenWhisk, we call our functions actions that's deployed and running on the platform. So in theory, I can now say invoke using the framework, hello, and it should go and make the API call to invoke my function and give me the results of my hello world service. There you go, right, hello world. So you can see using the templates, right, if you want to get started with a new provider, I don't really have to know anything about that particular provider. I can just scaffold a new boilerplate, click deploy, and then go and start to fill in the blanks. So let's look at a slightly more complicated example. This is called ASCII cows. And this is an application that I've already got running on AWS Lambda. So if I type service info, it'll give me the details about it. So it's a function that I've got deployed, and I've actually got an API gateway attached to it. So it's got a public API that you can call. And I can do that now to show you what it gives me. So this is called ASCII cows as a service. Every time I call it, I get a random ASCII cow comes back. You see, this is a very important microservice. And if you want an API key, you can come and contact me afterwards. Again, the source code is we have some very simple JavaScript which uses a third-party NPM module. I've got my package.json in there as well, and then I've just got the serverless YAML to set up my function called hello. And in the event configuration, I'm adding an API gateway event at the path /mu. Now, if I wanted to, for whatever reason, decide to deploy this to another provider, again, at high level, what you have to do is say, okay, well, now I want to deploy this to OpenWhisk. I have to change the handler for reasons that we will look at a little bit later. But then once I've changed that small configuration, I can say serverless deploy, and it should go and configure a new function on OpenWhisk, a totally different provider with an API gateway, and give me a API endpoint, a URL on a completely different cloud provider that provides me my same very important kind of cloud service in the background. So let's give this sort of 30 seconds to deploy, and then hopefully that will be up and running. So there we go, right? So it's deployed the function. Hopefully it's going to give me an endpoint now, so I can call HTTP GET on this slightly longer URL. And I should get back ASCII cows as well. So there you go, right? I've really quickly taken a very, very simple kind of serverless function, deployed it with an API gateway to another provider, and the serverless framework has done all the hard work of kind of taking care of the deployment packaging and all that kind of stuff for me. So let me jump back to the presentation now and kind of introduce some more things. So you can see, actually, I think the serverless framework multi-provider support is really cool. And maybe you think, okay, this looks easy, right? I can use the boilerplate to get started without really knowing any of the details, and maybe you'll get comfortable using some of these different providers, using them kind of concurrently, and maybe you would even move simple apps like that, like I just showed you, between different providers, and then you get really confident and you think, okay, I'm going to take my really, really big complex AWS Lambda app and I'm going to throw it over to OpenWhisk or Azure Functions, and it's all just kind of going to work, and the framework's going to take care of everything for me. But if you do that, what will happen is more dragons will be released, and you'll be back in the pit being turned into a kebab by Drogon, because although the framework can abstract away some of the difficulties of using service providers and make it easy to get started, the framework can't, and it shouldn't really try and abstract all of the differences between the providers away from you at a kind of code level. Because as I said, serverless frameworks or serverless platforms are very emerging spaces. All of the implementations are kind of vendor specific. There's no standardization between them. And what you'll find is a lot of your code won't work when you're kind of moving it between different serverless providers. So there's more dragons to kind of slay before you can get up and running. And the framework can help to a degree, but it's definitely not perfect. So if you want to be moving and building more complex apps that run on different service providers, there's a number of different things to be aware of that I'm going to kind of introduce you today, and hopefully give you some solutions to slay those dragons and make it a little bit easier to do. So if you're comparing the different service providers, one of the first challenges or dragons to be aware of is the dragon of interfaces. Right, with all service providers, you push your code into the platform without a lot of configuration, and what your code has to have is an interface for that particular runtime, and every time a function is called, the interface gets called, the parameters get passed in, and you do a computation, and you return the result. And that interface is different, obviously, for each different language that your provider supports, but unfortunately, it's also different between most of the different providers. So for example, let's look at what Node.js, the Node.js interface looks like for all of the big service providers, Lambda, OpenWhisk, Azure Functions, and Google Cloud Functions. So you can see they're all slightly different, although conceptually they all do the same thing, right? It's all just somehow registering a function that takes some parameters, obviously does the computation, and then returns the result to the callee, the thing that's called your function through the functional interface. And you can see, for example, they are, again, as I said, very same conceptually, but unfortunately slightly different. So it won't just work if you move them between different providers without some code changes. So we can see, how do you register your function? With Lambda and OpenWhisk and Google Cloud, what you do is you define your function as a property handler on the exports object of the module. In Azure Functions, it's slightly different. You define the function as the property exports on the module object. So again, that's a bit of a pain, slightly different, just different enough to be annoying. The other thing to think about, how do you get parameters into your functions? So for example, in OpenWhisk, you get called with one object, which has all of the properties of child parameters of that one object, all the request parameters. In Lambda, you get 3 parameters, event, context, and callback. In Azure Functions, you get a context object, but then every request parameter is a separate individual argument to your function. So again, no consistency really across any of the providers. And the other thing to think about is, how do you get data out? How do you kind of return the result, especially for asynchronous computations? So for Lambda and Azure and Google Cloud, they use a callback style approach, where you get a callback function passed in that you execute with either an error or your result of your computation. OpenWhisk allows you to either return an object directly, or for async computation, you can return a promise, which is kind of more modern JavaScript, but unfortunately isn't supported across any of the kind of other providers. So interface is definitely something to be aware of. A couple of things you can do if you're kind of thinking about how you might support different providers or migrate between them. One of them is to abstract away your core business logic of your service function from the actual definition of the handler for the particular provider, so that if you want to add another provider or refactor it to support another provider, all you have to do is change the kind of bit where you define the handler, not refactor your function. But this is actually something that I think the framework could do for you pretty easily with a plugin or something. I think using the framework, you could really just define your function using some kind of vendor agnostic interface, and then at compile time, when it's packaging up your application, your serverless app, it could just kind of compile using Webpack your function with the wrapper for the handler for this particular provider, right? It's something that I think could actually be handled by the framework, and maybe we will see in the future. Now, interestingly enough, when you talk about this challenge of consistency with the interfaces for serverless platforms, people have actually started to propose kind of standards or specifications for doing this in a kind of vendor-neutral way. This was something I saw was launched at ServerlessConf back in May 2010, and it was by a company called Stadlib, who have a kind of serverless offering which builds on top of AWS Lambda. It's kind of marketplace for microservices. And they have this function as a service language, which is an open specification that allows you to define your functions in a kind of vendor-neutral format. And you can also add the type information, and the vendor is supposed to be able to ingest this and just wrap it with the kind of functional interface of the vendor, and also do things like input-output validation on the type annotations that you've added. And in theory, that you could not be tied to one vendor. And this would be pretty wonderful to do. So they've kind of published this to generate some interest in the community, and I think it's a really interesting, and I think it would be something nice to see. Unfortunately, at the moment, none of the vendors actually support this, so it's not terribly useful, but it would be interesting to see if something like this did get traction in future. So interfaces, right? Interface is actually, I think, fairly easy to resolve and not much of a challenge moving between different serverless vendors. So the next dragon to slay is the dragon of runtimes. We know that if, as using service platforms, the service provider is completely responsible for setting up and managing your environment for you, right? So you're dependent on them to have runtimes that you particularly want to use. But one of the ways that vendors are trying to differentiate themselves is by providing new and more interesting runtimes. So we have to think about the runtime that runtime support when you're thinking of moving apps between different vendors, or which one you want to use as which particular environment they might have available. So if you look across all of I call it the big four, right? OpenWhisk, Azure Functions, Lambda, and Google Cloud Functions. There's a couple of key runtimes that are supported across all of them, and then some that are slightly more specific. So all serverless platforms generally support Node.js. It's like the first class service language, I think, anyway. And you can see also all of them support, at least these four, a modern version of Node. So OpenWhisk is Node 6.9.1, as is Azure, as is Google Cloud. Azure has 6.5, and AWS Lambda has 6.10, or they just released 6.10. They've been on 4 for quite a long time. So actually, if you're building kind of modern JavaScript for Node v6 and above, you shouldn't really have any problems running your code on any of the providers, which is pretty awesome. Python's also pretty popular as a runtime for service providers. Until recently, they've all supported Node v2, so 2.7 is supported on OpenWhisk, Azure, and AWS Lambda. And recently, both OpenWhisk and Azure Functions, AWS Lambda, announced support for Python 3, Python 3.6, and 0.1 and 0.0. So again, if we're using Python, you have quite a good range of providers to choose from, which is pretty awesome. Only Google Cloud doesn't support it at the moment. Java is a bit more kind of interesting. It's only supported on both OpenWhisk and AWS Lambda, but they're both V8, so you could swap between them relatively easily. No word yet on Azure Functions on kind of Google Cloud. So with some of the more common runtimes, actually, the choice of runtime is fairly consistent across the providers. But obviously, as I said, right, one of the ways they're trying to entice you to use their platform is by providing more interesting runtimes. So in OpenWhisk, one of the kind of default out-of-the-box languages is Swift. You can build your functions in Swift and deploy them without any kind of work or compilation. Swift was a language developed by Apple just originally for doing native iOS development, and then they open sourced it, and now it's become really popular as a language for doing everything with. You can build backend applications, and now you can build service functions by deploying them to OpenWhisk, which is pretty cool. But Swift at the moment is not supported on any other serverless platforms, so if you are thinking about moving it off, that's going to be a little bit more difficult. Azure Functions as well if you're big into the .NET stack, obviously Microsoft has very good support for all of things like C# and F# running as serverless functions on their kind of serverless implementation, as you can well imagine. But C# actually is not very well supported across anyone else at the moment. I know Lambda recently launched support for it using .NET Core, but it's not the full runtime, so you are a bit more specific. Google Cloud is kind of lacking here quite a lot. It doesn't support anything apart from Node.js, so they don't have a lot of support for that either. And then interestingly, another thing to consider is how easy it is to extend the runtime yourself. In OpenWhisk, you can actually, the runtimes are completely extendable. That you can push in a raw Docker container or image to act as your runtime. So you can pretty much run anything on the platform as a serverless function, right? If you want to do Rust or Go or, I don't know, Kotlin or Erlang or Elixir or Haskell, they're all kind of supported. And that's, I guess, one of the differences which is not supported in some of the more proprietary non-open source vendors at the moment. So again, runtimes is something to consider, especially if you want to move apps between providers or you're thinking about which provider for which application. Not all providers support the same runtimes. So as I said, it's not super difficult if you're sticking to some of the core ones like Node, but if you want to use something like Swift or F#, you're generally going to only have one vendor to use. Okay, third kind of point to consider is around events, because I think for serverless applications, serverless platforms aren't just around functions on demand. It's really about the event sources that you can connect to your functions to execute them automatically, right? Whether that's object stores or message queues or database updates or API gateways. That's a key part of this whole methodology of building serverless apps is the event sources. And again, a bit like runtimes, the event support across different providers is not consistent at all. So there's a core set of events which are generally supported by most service providers. There's the kind of primitives which most people kind of expect as kind of table stakes. So all of them support some kind of API gateway, right? OpenWhisk has API Connect, Lambda has something called API Gateway, as do Azure functions, and Google Cloud. It allows you to define public URLs for your functions with methods and paths, and then kind of invoke them on demand to do the processing of HTTP requests. And all of them have that kind of function or that kind of event source. Another common one is some kind of scheduling task. Often you want to connect your serverless functions to run according to some schedule, right? So every 5 minutes, every 30 seconds, every day, and all of them apart from Google Cloud currently support this, which is pretty good. So you shouldn't really have too much problem of using that kind of event source across most providers. They all also generally have a message queue and a database that you can connect to for events. So on OpenWhisk, you can connect to Kafka as your message queue. With Lambda, you've got a couple of options. Things like SMS is in there as well. For database updates, CouchDB is in OpenWhisk. Lambda, again, has a couple of options, things like RDS, and Azure functions, you have DocumentDB. So as a conceptual level, they have a similar class of events at a kind of high level. And I think in terms of connecting your functions to them, this is where Serverless Framework can kind of help a little bit. So this is the configuration for adding an API gateway, a public URL to one of your serverless functions on each of those 4 providers. And you can see actually the configuration is almost identical for most of the providers. For OpenWhisk and Lambda, it's exactly the same. So if you want to deploy an app, you wouldn't have to modify that at all. Google Cloud is very similar, except they don't allow you to specify the HTTP method as part of the event. You have to manage that in the function itself. And Azure function is a little more provider specific. They haven't followed the kind of standard that the others have done, but not hugely dissimilar. And again, if you wanted to connect your function on a new provider to one of these events, you actually don't have to know any of the details under the covers of how it works. You could just use the YAML to do this. So this is the benefit of using the Serverless Framework, right? It can abstract away some of the details of connecting functions to events. But unfortunately, what it obviously can't do is that it can't abstract away what the details, the properties of what that event will look like. So for example, when your function is called on OpenWhisk or it's called on Lambda through an API gateway, the properties, the request properties that get passed in are going to be very specific to that particular event provider. And the properties that it wants you to return back to control HTTP response are going to be very vendor specific. It's the same for all of the events for things like messages, message queues, and databases. So you're going to have to write code to be able to do it. You're going to have to modify your code to be able to do that. There's not really a vendor neutral way to be able to manage that. And there's nothing really the framework can do about that. Now, another challenge is obviously as the providers add more event sources outside these core of things like an API gateway and database updates, like the support for those across different providers is not so good. So I was looking this week to see how many event sources they have in total. OpenWhisk and Azure functions have 6 different event sources you can connect to. OpenWhisk actually allows you to add your own event sources in, so it's kind of extendable, but you do have to write code to be able to do that. Cloud Functions only has 3 out of the box, and Azure and Lambda obviously is kind of the most mature products because it's been out there for sort of 2.5 years. At the moment, has the most event sources in there with about 15. So if you want to get deep into some of the more vendor-specific event sources, so on OpenWhisk that might be our messaging layer. So we have a way to listen to events from mobile devices that are coming in. You know, that is going to be quite difficult to replicate on another provider if you were thinking about moving it or using one as well. So events is kind of a little bit more challenging. It depends whether you're sticking to very kind of core events like an API gateway, but you're still going to have to write some code for different providers to interpret the event parameters and obviously return a response. That's not kind of vendor neutral. Okay, the fourth penultimate dragon to slay is to think about the use of SDKs, because when you're writing serverless functions, you are often invoking other service functions from your function. You're often using other resources on the platform. And the way you do this is through generally the platform SDK, which is available in your runtime environment. The code for that obviously is going to be very vendor specific. So for example, here's an example in Lambda and OpenWhisk of how you invoke another service function on that particular platform. And you can see, you know, the code is identical in kind of what it's doing, right? You're requiring the SDK library, you're setting up the constructor, and then you're invoking the function, give it a name, and waiting for a response. But obviously that code is completely specific to that particular provider, and if you're moving one function to a different provider, you would have to kind of rewrite all of this, and that could be quite a lot of code depending on how much kind of integration you have with other services within your serverless function. So that's definitely something that could be a little bit more challenging. Interestingly enough, this was something that I saw the Serverless Framework also start to look at trying to resolve for you a little bit. I was digging around in their organizational GitHub, and I found this library called stdlib Node.js that they've been kind of working on, although I don't think they really talk about it, but it is out there publicly. And what it is, it's a standard library for Node serverless applications. And what it allows you to do is gives you a vendor-neutral API to say, I want to call this serverless function and using a name that you pass it. And when it's deployed under the covers, it will work out what provider you're on and then go and use the client SDK to be able to do that. So you don't have to tie yourself to the client SDK. You could use stdlib Node.js to give yourself a bit more of an abstraction. So SDKs is a bit more challenging, as you can see the emoji indicates, right? You know, it's very vendor-specific code. Libraries are very vendor-specific, and that could be a bit more work. So I was kind of interested to see Serverless Framework kind of try and start to come up with a solution for this, one of the challenges. So the final dragon, probably the most difficult to slay, is around your use of resources from your cloud provider in your service application, right? Yeah, because all of the providers, I think when you're building service apps, you know, I've heard this phrase that you end up embracing the platform, right? You end up, you know, if you want a database, you want a message queue, you want an object store, you don't generally go and run those infrastructure components yourself. You go and provision them from your cloud provider and let them manage it, right? That's the kind of paradigm of building serverless applications. And so, for example, on Bluemix, which is IBM's cloud, we have, you know, over 130 different services for you to be able to provision and use, and Azure and AWS and Google also have similar numbers of kind of cloud components. And depending which ones you use, it can make it tricky to use other providers for your serverless apps. So for example, I think you can kind of categorize cloud services into a kind of open source and non-open source. So for example, if you're using kind of mainly open source components in your cloud applications, things like Redis or Elasticsearch, Kafka, MySQL, generally every cloud provider these days allows you to provision those and use them within your application, right? You know, you're just using a client library which connects to some external URL in there. The cloud provider will run this for you as a hosted service. You don't really have to worry about it. So obviously, if you were going to move or use a different application, a different provider for your service app, you can generally provision that same kind of open source component on whatever provider you choose. Obviously, you can still connect generally across the different cloud providers, but maybe for latency, you think that's not kind of a great idea. So actually, in terms of using resources on a cloud provider, if you're mostly using open source components, it's not too difficult to move or use different providers. One of the challenges, obviously, is probably with some of the more kind of vendor-specific services, right? The secret sauce, where they kind of lock you in because that's the really good proprietary technology. So, if you're using IBM's cloud, Watson is one of the big kind of APIs and services that developers like to use, and is very obviously IBM specific, is not open source. So obviously, although they're APIs and you can use them from anywhere, you can't really provision them through other cloud providers. Likewise, if you're a big user of AWS, maybe you're using Redshift for doing big data analysis, that's a very, very proprietary product that you can't really provision and use on other kind of cloud providers at the moment. Again, on things like Azure and Google Cloud, they have things like Cosmos and Spanner, which are these new, cool, funky, auto-replicating, geoscaling databases that people are really excited about using with serverless. And obviously, they're the platform's kind of secret source. That obviously, they're not open source, and you can't really run anywhere else. Although you could kind of talk to them cross data center. So, if you're thinking about kind of cloud resources and different providers, it's something to definitely consider, right? If you're heavily locked into your platform and you're using every service under the sun, it's probably going to be more difficult, a lot more work to replicate that on another provider. If you stuck to mainly open source components, then it's not really too difficult, I think. But it's something definitely to consider, and it's definitely, in theory, the most challenging of those dragons that you want to slay. So I said at the start of this talk, right, that serverless, I think 2016 was the year that serverless kind of blew up. And the reason that it kind of blew up was that all the other big cloud providers kind of came on board and launched their own serverless solutions, right? Serverless started in 2014 with Lambda, but now you have a dozen different providers. Every big cloud player has their own serverless platform, and they're trying to differentiate themselves by adding new features and runtimes and being open source and all this kind of cool stuff. And as developers, this is great for us because now we can think, okay, what's the best provider for my particular application? And we can get all the benefits of the vendors competing against each other. But, as I said, you may be excited about using, Node v8, which is only available on a certain runtime. And you might want to go and sign up for a new vendor, but you might think, well, is it really worth it, right? Here be dragons, because do I really want to spend all that time learning another vendor just to use a newer version of the Node.js runtime? And this lack of standardization has kind of hurt people a little bit, and I think it's been a bit of a barrier to adoption. And this is why the serverless framework, I think, is really, really important in helping developers at least abstract away a little bit some of the differences between the vendors and make it get easier to kind of get started and kind of try things out. And as of 1.6, which came out about 3 or 4 months ago now, you can actually do this for all of the big 4 service providers. So I want to kind of encourage everyone on this call today, right? If you're building service apps, right, don't be scared of the dragons of different service providers, right? Using the service framework, you can actually make this much easier to do, right? Summon your inner Khaleesi, tame those dragons, and use the framework to get started with the boilerplates and scaffolds. You can start to play around and take advantage of the features without really having to dig into the intricacies, at least to begin with anyway. So just before I end, I want to kind of give a little plug. If you're thinking about using another service provider, definitely go and check out what is now Apache OpenWhisk. This was IBM's offering that we open sourced when it was announced about 18 months ago, and now it's been donated to Apache. So it is a fully open source platform that you can run it locally, you can deploy yourself, or you can go and use one of the hosted providers. IBM gives you a full instance to play with. We actually have 3 different vendors now using it. Adobe have been on board for a while, and as of about a month ago, Red Hat announced they were deprecating their own service platform, which was Fission, I think, and they've adopted OpenWhisk wholesale. There's a really big open source community around it, and that's where we kind of all hang out. So definitely want to try out for some of the reasons that it's open source, and the runtimes are completely extendable. You can run any runtime you want on the platform. You're not restricted to the ones that come out of the box. And then a final plug just before we kind of go to questions is that if you're interested in serverless and you happen to be in London on July 7th, come check out a conference called JeffConf, which I am a co-organizer for. It's a conference for people using serverless to come and talk about what they're doing and listen to some of the really important people in the space talk about where things are going next. And it's going to be in London on July 7th. Just Google for JeffConf. I don't think anything else is called that at the moment. It's very, very cheap. We try to make it very affordable for the community. So tickets start from only £35. That's only £35. And they're about 2/3 sold out at the moment. So you don't have a lot of time to buy one. And there'll be an unconference session in the middle. You can come and talk about what you're doing. So if you're interested in that, go and buy a ticket for JeffConf. So with that, I'd like to say thank you very much for coming, and I think we probably have about 5 or 10 minutes for questions now. If not, you can always find me on Twitter afterwards at ThomasJ, and yeah, you can ask me any questions, or you can come onto the OpenWhisk Slack, and we're always on there if you're kind of interested to find out more. So thank you very much for listening. If you've got any questions, you can ask now. You can find me personally later on Twitter.
Yeah, James, we have a couple of questions from the attendees.
Okay.
One of the attendees is asking, is it an impression of mine, or AWS Lambda seems far more advanced than the competitors so far?
Yeah, that's a good question. I think naturally Lambda has been, Lambda's been out there for 2.5 years, I think. So, it is the longest serving product. It's probably the most mature at the moment as well. So I think naturally, just because it's been out the longest, it has some of those better features in terms of things like the event sources. But I think the whole space is evolving very, very quickly. If you look at the other vendors, and not just OpenWhisk, you look at Azure Functions, they're evolving rapidly. They're evolving rapidly, and they all obviously know that Lambda is the market leader. So they're trying to add features in that differentiate themselves by quite a lot. So for OpenWhisk, that would be that one, it's open source, and two, the runtimes are extensible, and it has a slightly more complicated event model. If you're looking at Azure Functions, obviously their .NET support is much, much better than any of the providers because not all of that technology is open source. So it's a good question. I think understandably Lambda has been out there for longer, so it's probably the most mature at the moment, but I think everyone is moving so quickly that actually there's lots of compelling reasons why you might choose another vendor at the moment. But as I said, you don't actually have to be stuck. I think you don't have to stick with one vendor. You can use different vendors for different applications. If you want to use a particular runtime for a particular service app, you can do that and deploy it to one particular service provider. It doesn't have to be an either-or where you only use Lambda for everything, or you only use OpenWhisk for everything. You can now choose which one you want to use, and the service framework means that you have some consistency in the development workflow across them all.
And we have another questions. Can you give a few examples of companies using the serverless framework today?
That's a good question. I think not. So I don't work for the serverless framework people, so I'm not really au fait with that. I mean, there's lots and lots of them. I think Nordstrom use it because I see them at hackathons and things like that. So there's lots of big companies using it, I believe. If you go to a serverless meetup, most of the talks are around deployment and how you do deployment, and I've seen serverless framework mentioned a lot. I think if you go to their website, then they'll probably have a list of all the big people using it. But it's the serverless framework undoubtedly is the most popular framework for building serverless apps out there. It is much more popular than Apex or Zapper or Chalice, and it's just growing incredibly. So they have tons of users. They have a really vibrant community, open source. They have loads of third-party plugins that people create. There's good docs. So yeah, I think I really like it. I use it every day, and I think it's an awesome open source project.
And just out of curiosity, just a question that I'd like to ask you about the JeffConf.
Yes.
Are you gonna have like a keynote and something like that? If you want, feel free to add like more details. I'm happy to know more about that.
Yeah. So JeffConf is so we decided to organize it to really focus. We wanted to make it really affordable for service developers because we feel obviously tech conferences can get very expensive because they assume that everyone relies on their company paying for them, and I think that's not always very inclusive. So for us, we wanted to make something that was one, very affordable, but also very community focused, right? So rather, get developers that are talking about using serverless rather than often having vendors talk about what new features they've got in their products because they sponsored and paid loads of money. So we've got a mixture of talks, and we have a kind of unconference session in the middle for 2 hours where anyone can turn up on the day and talk about anything. The keynote speaker is someone called Simon Wardley, which many people might have heard of. He's a really amazing person who talks about technology, future trends, and has been heavily involved in, he's been heavily promoting serverless as the future for development and thinks it'll be the de facto standard for all cloud applications in 3 to 5 years. So if you haven't checked out Simon Wardley's talks before, he's talked at all the big conferences, all the Avali events. go and check him out. He does a really funny, engaging talk about strategy and why we're bad at it, and how you can kind of predict the future, as he calls it. And yeah, you can come and see Simon speak. Normally, to go and see Simon speak, you have to go to one of these big, very expensive conferences, which cost like $1,000, and you can come and see him at JeffConf for $35. So we're going to have people like that. We've got the Financial Times in the UK coming. One of their developers talking about what they've been doing with it. We've got Lorna Mitchell from IBM speaking about doing Alexa development and fun things you can do. So yeah, we've got a real mix of people, but it's all very developer driven. There's no real vendor pitches. And then yeah, excitingly for me, there's going to be a 2-hour kind of bar camp in the middle where people on the day could just come and talk about anything. So you can get involved. It's not just going to be kind of sitting and listening. So yeah, I think most of the speakers have been announced. They're on the kind of website now, so you can go and check them out. But yeah, it's going to be a very exciting event. It's very affordable, and yeah, hopefully it'll be one of many. It's been organised in conjunction with the London Serverless Meetup community, which is a very popular meetup that kind of already exists. So yeah, it's going to be super busy, and it will be sold out in about a week or so. It's 2 weeks on Friday.
Yeah, it's going to be an amazing event. I'd like to thank you and all the crew for organizing this event in London.
Yeah, thank you. It's going to be the other two people, Anne Stanley and Paul Johnson, that people might know, the other key organisers, do a lot of the hard work. So yeah, it's going to be fun. And if people are around, then definitely come by and say hello. Yeah, JeffConf 2017.
One last question. Is the only way to deploy serverless is via CLI interface?
Yes, it is. Yeah, the serverless framework is purely a CLI tool for doing deployment. I mean, people often will use the tool in their CI or kind of continuous or CD, continuous deployment pipeline. So they'll, it's not that developers don't often, for production apps, you will not be typing serverless deploy yourself, right? You'll be committing the code to GitHub and then serverless framework in the back end. The CI, Jenkins or Hudson runs and installs the tool and then uses that to deploy. So yeah, it's purely a CLI tool, but obviously people will use that CLI tool in their continuous deployment and build pipelines to push apps into production.
So I think that's all the questions that we got during your presentation. I'd like to thank you, James, for presenting this amazing session.
That's fine. Thank you very much. Thank you for inviting me. Thank you, everyone, for attending. And if you have any questions in future about Serverless Framework or OpenWhisk or both of them combined, if you find me on Twitter, then you can just send me a message. And if you want to try out OpenWhisk, I'd say come and join the Slack channel, because we have a really popular Slack channel where you can get help from everyone kind of live and kind of connect. So yeah, and hopefully, maybe I'll see some of you at JeffConf in a couple of weeks.
Yeah. So I'd like to encourage everyone who's in London the first week of July to stop by the JeffConf. It's going to be an amazing event. And if you have other questions, also keep an eye on cloudacademy.com/community to answer your questions, and our cloud experts are more than welcome to help you guys. So thank you, James, for today's presentation, and I hope I'll see you soon.
Okay, yeah, me too. Bye-bye, everyone.
Bye, everyone. Thanks again.